Good morning and good afternoon, everyone. Welcome to Asian Productivity Organization Presents Productivity Talk. I'm Kenji Watanabe, Multi-Country Programs Division. Nice to meet you, everyone. Today's topic is marine debris and sustainability. Ocean pollution is now serious. Ocean is filled with garbage which humans discarded. Such garbage deteriorates water quality of sea and harms ecology of ocean. As a result, it endangers human life. Today, we invited the best guest speaker on this topic, Dr. Hideshige Takada. He is professor, Laboratory of Organic Geochemistry, Tokyo University of Agriculture and Technology, Japan. Dr. Takada, thank you for coming today.
You're welcome. Thank you, Mr. Watanabe, for your very kind introduction. Good morning and good afternoon, everyone. I'm glad and honored to be invited to Productivity Talk in your institution today. Thank you.
Dr. Takada, I think viewers have interest in your research and activity in your university. Could you briefly explain your research and activity?
Okay. So we study environmental pollution by mainly field work. So we normally we study on organic pollutants such as synthetic detergent and petroleum hydrocarbons, persistent organic pollutants, and endocrine disrupting chemicals and microplastics. Normally, we go to the field to take the samples, including water, sediment, biota, and plastics. In the laboratory, we analyze pollutants by using our special instrument like this. So let me show you our activity to collect microplastics in Tokyo Bay as an example and introduction. We made one-day cruise on Tokyo Bay in this November. We put net with 0.3 millimeter mesh to collect new stones in surface water. After 20 minutes deployment of the net, zooplankton and microplastics were collected, taken in the net. Because microplastics are suspended together with zooplankton, we can see microplastic together with zooplankton. But it's too small. I will zoom in. So these white and blue and red fragments are suspected to be plastics by using laboratory instruments, the FTIR. We have confirmed that these are microplastics, which are topic of my talk today. Thank you for your attention.
Thank you very much, Dr. Takada. Your research is very important for human and the earth. What's happened in ocean environment?
Okay, so due to increase in plastic waste and poor waste management, huge amounts of plastic debris are stranded on world beaches like Tokyo, Japan, and also the beach in Lebanon. Most abundant plastic items are plastic debris are PET bottles, as you can see. Stranding of plastic debris on beach is common in urbanized areas such as Manila, Philippines. However, even on beaches in remote islands, 100 kilometers far from urban centers, we see plastic debris too. These plastic debris are relatively large, but pollution with smaller plastic debris is a more serious problem. Photo in left-hand side is microplastics we collected in Tokyo Bay, as I mentioned earlier. Microplastics are defined as plastics less than 5 millimeters. Right-hand side is photo of microplastics collected from surface water of Western Pacific, 1,000 kilometers off main island, Japan. Recent researches indicate plastics and microplastics are floating and suspended in surface water all over the world. And more than 5 trillions of plastics are suspended in surface water. In this map, red means highly polluted areas with plastics. So as you can see, south edge of Eurasia continent is highly polluted with plastics. This is due to these areas are close to highly populated zones. According to Professor Isobe of Kyushu University, East Asian Sea is hotspot with higher abundance of microplastic in surface water. Abundance of microplastics in East Asian Sea is one order of magnitude higher than the other areas in the world. So floating plastics are just a portion of total plastic in marine environments. Microplastics can be accumulated in bottom sediments. Sediment is important thing of microplastics. To reconstruct the pollution history, we collected sediment cores from Asian waters, including Tokyo Bay, Gulf of Thailand, and Manila Bay. Vertical profiles of microplastics concentration in sediment cores indicate the microplastic pollution started in 1960s or 1970s. These correspond to the period when we started mass consumption of plastic in the society. Occurrence of plastics in sediment layers, that is geological media, is typical indication of Anthropocene.
Thank you very much, Dr. Takada.
You're welcome.
Ocean pollution is much more serious than I imagined. Especially plastic debris is serious. Why ocean was polluted by plastic debris so seriously?
Mhm. So let me start with the production of plastics. On global basis, more than 400 million tons of plastics are produced annually from petroleum. Half of the produced plastics are single-use plastics, such as plastic shopping bag and PET bottles and disposable lunchbox and so on. They are easily to be plastic waste, but the plastic waste are basically subjected to the waste management on land. However, some of plastic waste escape from waste management on land and trashed on ground and road surfaces. Situation is more serious in economically developing countries. This is an example of the tropical Asian city where the large amount of large amount of plastic debris trashed on the bridge. Because most of the plastics are lighter than water, they are washed to stream by rain. Plastic trashes are further washed down to the ocean through rivers. Finally, they reach the ocean. Thus, the source of plastics and microplastics in ocean is on land, and rivers carry waste plastic to the ocean. So please, let me show you an example. Please show the video. Yeah, this is an example of river in tropical Asian country. Trashed plastic on land are washed by frequent tropical rains and carried to the ocean through these rivers, finally to the ocean. Okay, so please stop the video. Due to their persistence and lightness, plastic make long travel on sea surface. During their floating on sea surface, they are exposed to UV radiation and physical impact by wave and wind. And they are fragmented into smaller pieces, finally to be microplastics. Therefore, the source of microplastics is our daily use, the disposable plastics. But in addition to the fragmentation of the single-use plastics, there are some other sources of microplastics to the environment. They include plastic resin pellets and microbeads in facial cleaners and cosmetics, and wear of clothes made of synthetic fibers such as the polyester or acrylic resin, and also the sponge, also the artificial loam and tire wear particles. They are supplied to marine environment through sewage, effluent, or surface runoff during rain events. So we have many sources and many routes of plastics and microplastic to the ocean.
Thank you, Dr. Takada. I understand human is responsible for such pollution. How affects such plastic pollution on ocean ecology?
Okay, most serious problems with marine plastic is their ingestion by marine organisms. So large plastic fragments are ingested by large animals such as whale or sea turtle. For example, whale stranded on Greek beaches were investigated for their stomach contents, and 9 among 34 individuals contained plastics. Plastic shopping bags were most abundant items. The authors stated that gastric blockage from plastics was presumably lethal in 3 whales. Seabirds are most sensitive to plastic pollution. For example, great shearwater from an island in sub-Antarctic Ocean had 200 pieces of plastics in its stomach, like this. In the world, we have 360 species of seabirds. Among 360 species of seabirds, 180 species, that is half of seabird species, have been reported to ingest plastics. So smaller plastic fragments, that is microplastics, are ingested by smaller organisms such as fish and shellfish. We studied anchovy or sardine fish in Tokyo Bay. In the stomach of the 80% of anchovy individuals in Tokyo Bay, we found microplastics around 1 millimeter. So we conducted survey of microplastic in benthic organisms, benthic small organisms in urban estuary in Japan. The organisms include goby, crab, and clam. We found smaller and invisible microplastics down to 50 microns in the soft tissue of goby, crab, and bivalves in the estuary. Nowadays, microplastics are detected in fishes and bivalves in many locations in the world. Approximately 500 species of fishes have been reported to ingest microplastics. This clearly decreases the food security of seafood. So because plastic cannot be digested or biodegraded in marine organisms, they are xenobiotics for marine organisms. They pose physical damage on marine organisms. For example, gastric blockage from plastic caused lethal damages to the whales stranded on Greek beach. Regarding microplastics, many laboratory experiments demonstrated that microplastics pose physical damage such as inflammation. That is, they pose particle toxicity to the organisms, including human.
Thank you very much, Dr. Takada. The biggest victims of plastic pollution are fish and seabirds. How plastic pollution affects human?
Okay. So in addition to physical impacts, plastic pose chemical threat to marine organisms and finally to human. Marine plastics contain additive chemicals. They are originally compounded into plastic products on their production. Additives are essential components of plastic products to maintain or improve the property of polymers. Various additives are compounded to plastic products. They include phthalates as plasticizer and nonylphenol and bisphenol A as antioxidants, benzotriazole and benzophenols as UV stabilizers to prevent the weathering or fragmentation of plastics, and flame retardants such as PBDEs and DBDPEs. Unfortunately, some of these additives are endocrine disrupting chemicals because they have ability to bind with hormone receptors when we and the other organisms they uptake these chemicals, and finally they disrupt endocrine system and cause disorders in reproductive functions and decrease productivity. For humans, they may increase endometriosis and breast cancer and decrease sperm count. Recently, we surveyed the endocrine disrupting additives in various plastic products, including plastic bag and straw and polypropylene mask and float and seeding pot and so on. Among 21 plastic items, endocrine disrupting additives were detected in 19 items, and only 2 had no additives. This means that we cannot avoid endocrine disrupting chemicals as long as we use plastics. Because most of the additives are hydrophobic, they are retained in plastics, even they are discarded to seawater because they cannot dissolve or dissolve into the water, and they have high affinity with plastics. Therefore, we have detected various additives in microplastic in marine environments. Because the marine plastics are ingested by marine organisms, they internally expose toxic chemicals to marine organisms. But most of plastics are excreted, but some of the chemicals are leached from plastics and accumulated in the tissue of organisms which ingest plastics. This is the bioaccumulation of chemicals. This bioaccumulation of chemicals decreases the quality of seafood. Furthermore, accumulated chemicals may decrease the productivity of seafood because chemicals, endocrine disrupting chemicals, affect reproductive system and also reproductive function of organisms. So recent field observation and laboratory experiments using seabirds and hermit crab and bivalves have demonstrated that plastic additives are transferred and accumulated in the tissue of organisms which ingest plastics. Through the food web, the additives are indirectly exposed to human beings. That is, microplastics accelerate the indirect exposure of plastic additives to humans. On the human side, we see alerting signals of endocrine disruption, decrease in sperm count, increase in breast cancer, and endometriosis. Furthermore, plastic additives, that is bisphenol A, was detected in blood of endometriosis women. Contribution of plastic additive should be quantitatively evaluated as an urgent task. However, to reduce our exposure to endocrine disrupting plastic additives, usage and consumption of plastic in our society should be reduced as precautionary action.
We must stop plastic pollution right now. In order to improve ocean environment, what should we do?
Yeah. So since 2010 or earlier, the international society has been tackling on such activities to reduce plastic pollution in marine environments. As a consequence of such the international activities, in 2019 G20 summit, which conducted in Osaka, declared Osaka Blue Ocean Vision. In the vision, we aim zero emission of plastic litter to the ocean by 2050. So let's consider how to achieve this goal, that is zero emission of plastic to the ocean. To reduce the input of plastic waste from land, improvement of waste management is the key. Let me see treatment options for plastic waste on land. They include landfill and incineration and recycle. Let's consider landfill first. Landfill generate leachate from dumped garbage like this. The landfill leachate contain high concentrations of endocrine disrupting chemicals derived from plastics as additives or degraded polymers like this. They pollute rivers and coastal waters and groundwater. Basically, we have limited space of landfilling. Landfill is not sustainable option. How about incineration, including waste to energy, WTE? Because plastics are made of petroleum, their incineration leads to emission of net emission of carbon dioxide, greenhouse gas. It accelerates global warming and it's not consistent with Paris Agreement. In addition, incineration of plastic waste potentially generate toxic chemicals such as dioxins. We have technology to reduce the release of toxic chemicals by combusting the plastic waste at higher temperature. However, construction and operation of such modern incinerators take huge cost. The lifetime of the modern incinerator is short because of combustion of waste at higher temperature. Therefore, incineration is not a sustainable option. How about recycling? So basically, recycle has some limitation. First, recycle takes efforts, time, and cost and energy. Therefore, the recycling emit carbon dioxide to, in some cases, to accelerate global warming. So fundamentally, eternal recycling is impossible because of breakdown of carbon-carbon chemical bond. Quality of plastic is getting worse as repeated recycling. This is called as downcycling. Chemical recycling may avoid the downcycling to create higher quality recycled plastics. But chemical recycling takes energy. Plastic is not sustainable resources. Also, we have to be careful with recycling of hazardous additives and adsorbed chemicals on recycling, especially on upcycle of marine plastic debris. There have been some reports that toxic additives were detected in toys for children, which were made of recycled plastics. Thus, recycle is limited option. So, landfill and incineration are not sustainable option. Recycle is limited, therefore reduction of plastic consumption is the first priority. We have to close the tap to prevent marine plastic pollution and stop global warming. I have discussed about these issues in this book, The Plastic Waste Management Hazards, published as a report by IPEN, International Pollutant Elimination Network. The link is here. If you are interested in, you can download and read the report. In any way, my proposal toward sustainable society is as follows. So large reduction of single-use plastic, especially packaging plastic, is top priority. Reduction in packaging can be established by reduced transport of resources in decentralized society, and plastic should be replaced by biomass, glass, metals, and China. Even after these efforts, we have to use some portion of plastics. So minimum required amounts of biomass-based plastics are utilized and recycled by using safe additives. To utilize safe additives, we have to establish positive list of additives for plastic general. In any way, we have to position or place the solution of plastic issue in establishment of decentralized sustainable society. Okay, thank you very much for your attention.
Thank you, Dr. Takada. We need to minimize to use plastics. So now I would like to introduce questions coming from viewers in chat box. Questions are coming from Japan. 3 questions. The first one is, please listen.
Yep.
Can microbes be used to make solution of marine debris?
That is this question could be some plastic can be degraded by microorganisms. Yes, there are several efforts to make or to produce the biodegradable plastics. Basically, biodegradable plastics are not perfect solution. It's a partial dissolution because biodegradation depends on redox condition. That is availability of oxygen. In water column, biodegradable plastic can be degraded. However, in bottom sediment, oxygen is depleted and condition is normally anoxic, and therefore biodegradable plastic cannot be degraded in bottom sediment. Actually, in Tokyo Bay, we detected microplastics of biodegradable plastics in bottom sediment of Tokyo Bay. They must have been partially degraded in water column and stored in anoxic bottom sediments. Biodegradable plastic should be properly treated on land before they reach at sea. We have to collect biodegradable plastics separated from the non-degradable plastics and degraded them in composter and or similar instrument to degrade organic matter. We have to establish system of collection and degradation together with material development of biodegradable plastics. Okay, that's the answer to the first part of the question.
Thank you very much. Responding question one. So move to second question. What
Yeah.
are the new research on this in Japan?
Yeah, new research in Japan is we have been conducting some research on the bioaccumulation of plastic additives from the ingested plastics to the marine organisms and finally to human. So we conducted such the bioaccumulation of the plastic additives by using the seabirds, also the beached organisms, that is the hermit crab and bivalves. And we demonstrated that our studies demonstrated that the additives, some portion of additives can be bioaccumulated through the transfer and through the dissolution of additives into digestive tract and transfer to biological tissue. So far, the hydrophobic additives are thought not to bioaccumulated because they are retained in the plastic matrix, but due to their fragmentation to be smaller sizes, also the oily or surface active the digestive fluid facilitate the dissolution of additives into digestive fluid. And finally, the additives, plastic additives, can be accumulated in the tissue of organisms. That's the answer to the second question. Also, I have one more example. We recently we measured very small microplastic, less than 10 microns. Such small microplastics can be accumulated in the tissue of the organisms and marine organisms and human. The larger microplastic can be excreted from human and marine organisms, but smaller microplastics, less than 10 micron, can be accumulated in the tissue or organ of the marine organisms or human. Such studies was conducted by Professor Oshima in Kyushu University.
Thank you very much.
Welcome.
So one more question is what are the other methods can be used?
It's difficult to catch the meaning of the question. The other method can be used. That is probably some replacement of plastics. So to other as replacement materials for plastics, we can utilize biomass itself or biomass-based plastics. So biomass means the paper, wood, and grasses. So we can utilize such the plant-based the biomass instead of plastics. Also, if we really need such, if we really need plastics, so we can synthesize the biomass-based plastics from biomass, basically from the cellulose. That's the answer to the last question.
Thank you very much, Dr. Takada.
Okay.
I have some questions. So, plastics in sea, how long does it exist in sea? I think plastic cannot be disorganized naturally, I think.
Mhm.
So, 100 years, 1,000 years, I'm not sure, but how long plastic remained in ocean?
Mhm. So if we focus on only the water column or seawater, surface water,
Mm,
it can persist in several months or several years.
mm,
But the plastics are fragmented into smaller pieces and they are coated with biofilm and finally they are settled down to the bottom sediment. Once
mm,
the microplastics are incorporated into bottom sediment, it can last for thousand or more
mm.
10,000 years because
1,000 years.
or more
No. Or
no
more.
no UV radiation came.
Mm,
Also, it cannot be degraded by microorganisms. So, because the condition is normally not favorable for the microorganisms and
mm.
UV radiation. So, it can stay there for almost forever.
Almost forever.
Yeah.
Yeah.
So, in future, if we collect the sediment core, we may see some layers of plastics in the sediment core.
Mm. Okay. Are there any good, effective way to take them away out of oceans?
Yeah, it's a good question. It's so difficult to remove, collect and remove the small microplastics. But the one way is we can collect and remove large plastic debris on beaches. The, due to the physical oceanographic the rules, the large plastic materials can be stranded on the beach,
Mm,
where the plastics are fragmented into smaller pieces, that is microplastic by UV radiation on the beach due to the UV radiation and heat. Before it goes to the microplastics, if we can collect and remove large plastic items, we can stop the generation of the thousands of the microplastics. So one way is the beach cleaning to collect and remove large plastic items, large plastic trashes on the beach. So beach cleaning is the very effective way to reduce the microplastic pollution. But the volunteers and
mm,
NGOs who go to the beach every week, they say every week they see new plastic debris on the beaches, even after they clean the beaches. This means we have to reduce the inputs of the plastic waste to aquatic environment. So we have to close the tap to reduce the consumption of the single-use plastics. Otherwise, the amount of plastic on the beach would be increasing. Also, the amount of microplastic in the sea would be increasing. So closing the tap is the very important and essential way to reduce microplastics. Close the tap, and also we can just wait for the sedimentation and settling of the smaller microplastic to the bottom.
Thank you very much.
Welcome.
Yeah, you are right. We need to do effort to clean up beach and ocean because it is a responsibility of human. We need efforts to clean up a beach and ocean. Yeah. Anyway, thank you very much. Now time is coming. Dr. Takada, please give your message to viewers.
Yeah. Okay. The plastics and the associated chemicals harm the marine organisms and also the human ourselves. So we have to reduce the consumption of the single-use plastics in our daily life. That's the simple but the necessary solution, and to save our ocean and to save our health. Thank you very much for your attention.
Thank you very much, Dr. Takada, for your coming today and informative presentations. Your research is really important for humans. Please continue this activity and wish you a further success.
Yeah, thank you. We will continue. Thank you.
Thank you very much for viewers today. Today is the last live program of APO Productivity Talk this year. Thank you very much for your watching APO Productivity Talk this year. I would appreciate your support on it next year too. Have a happy holidays. Bye-bye.
Bye. Happy holidays.